Hello, everyone, and thank you for joining today's webinar. My name is Joy Ruff, and I'm a product marketing manager here at Parasoft. Joining me today is Ruben Wildeboer, who works in the Enterprise Solutions Engineering team at Parasoft. He has been with the team for over 6 years and has over 10 years of software development experience. For this event, please be sure to enlarge your BrightTalk Beautiful screen, and if the video appears blurry, increase the video resolution in the BrightTalk display settings in the browser window. Well, today we're going to show you a live demo of how Parasoft enables its customers to accelerate CICD feedback for feature branch development. Ruben, over to you.
Yeah, thank you, Joy. So, hello everyone, welcome at the webinar. Like Joy just mentioned, we are going to talk about feature branch development, and then mostly in context of quality, software quality, of course. Actually, from two perspectives. So we will start with the development in the IDE, and we will give you some insight on how you can get quick feedback on quality aspects of your software. And later on, we will move to the pipelines, some examples on how to implement this technology in your pipeline as well. If you have any questions during the webinar, feel free to post them in the chat. We will address them in the end of the webinar. So yeah, with that being said, I think we can get started. But first, a quick refresh on what feature branch development actually is. So first of all, it's like a popular way for developers to collaborate on the same code base. So basically what happens is that from the master branch in version control, you have the possibility to create like feature branches to work like in a different branch on the code base. The whole idea is here that later on, when the feature is ready, this branch will be merged back in the master branch. So this gives you the ability to work on within different branches. You can have like multiple of those feature branches, where you can work basically in isolation of the master branch. So here we see a quick picture of that. So the purple line illustrates one feature branch. You can see like we are still then working in that feature branch, and obviously you want to make sure that before merging to the master branch that quality of the software is on an appropriate level. And that's what we will show how to make sure that software basically complies to your standards. And we will show you how you can do that from actually both within IDE and from the pipeline systems. So why is working with feature branches actually useful? So there are a couple of reasons. There are probably more, but well, probably the most important ones. First of all, like I mentioned, collaboration. It is easier to work on different features in parallel. So you can have like people working on the main branch still on the master branch still for example, maybe for bug fixes. But when you move on and you want to create like different features, or you still have to like maintain maybe a specific release of your software, for those purposes you can create feature branches. Basically you work in parallel, so a different team can work on a different feature branch. And you don't interfere with each other's work. This also reduces the risk of introducing defects in the main code base. So that's actually point 2 here. You work in isolation. So if you work on those new features in the feature branch, and you make probably some mistakes, introduce some bugs maybe, the main master branch will not be impacted by that. It also helps you to get control of your code quality. It's easier to work in the feature branch and to basically say that you have like specific conditions on the software that you add in the feature branch, and that you want to have it comply to a certain standard. So yeah, this actually leads to more maintainable code, and it reduces the likelihood of introducing defects. Which is also like an important thing is that with feature branches, it is easier to deliver smaller increments. You can basically allow for smaller changes, making those changes in different feature branches. It can be easier to work on a small feature and then deliver the small increment by merging back into the main branch. Well, it can also help with code review. It makes it easier to do code reviews. Also, unit testing can help in that area, of course. If you have like some nice unit tests on the code, it is easier to do the to do the code review. Basically, because it's a more manageable chunk of code that you have to review at that point. And also the feature branch will enable you to do some experimentations. So maybe you have some branches where you want to implement some technologies, some techniques that are just like a tryout, and for that you can use the feature branch as well. Now we move to the quality process, and there are actually two perspectives of quality which we will talk about today. So first of all, we have static code analysis. Well, Parasoft provides static code analysis focused also on security standards. So you can check your code to see if it's compliant with OWASP and CWE, for example. You could do more things with static code analysis, like things like metrics, for example, see cyclomatic complexity to check if stuff doesn't get complex. And in general, with static code analysis, you check on code quality. Are there like duplicate or unused code blocks? Are there like possible bugs? Things like that are being checked. And that is one of the things that you can do in the pipeline, of course, together with executing your unit tests. And I'll actually show you this later on in the webinar. So how it affects the pipeline is that with enterprise analysis, it's more than a simple checker. Parasoft provides things like flow analysis, checks, and a unit testing platform where we can run the unit tests. And with the unit testing, actually the logic there is that each test is supposed to run quickly. But the main problem there is that with large projects you have like thousands of unit tests, so execution times increase. In some projects we see customers having like unit tests that run for hours. Well, you can imagine that specifically if you run those tests within the feature branch, you might not be like interested in the output of all of those tests, like for every execution, because it takes like hours to get feedback on your code change. So for that, it would be helpful to run the relevant tests, and that is what we will show later on. So when do we actually want to run those tests? Well, first of all, the developer works in the IDE. The test that runs in the IDE, they have to run fast. Like you want to get feedback within the minute. Well, a popular technique for this is to use commit suites. But the problem here is that commit suites might not handle the cases related to the code changes always. What usually happens is then that the code is then committed in the repository, and then the test is being executed in the pipeline. Um, there the test has to run fast to get like feedback within 10 20 minutes. And there you can make like a separation maybe between the nightly full run, where you say, well, um, let's execute the complete set of unit tests, like do a complete run, which can take for big projects like ours. And you can have a separate run within your CI/CD pipeline. So when are you sure when you tested your changes? Well, first of all, you want to have the feedback in the IDE and in the pipeline, but you get most of the feedback after the nightly run. But that might be too late, right? If you get like feedback at that specific point, then it would be better to have that feedback much sooner. And that's where we look into. And how we can do that is with smart test execution. So looking at the code base, we are then focusing on change. So the code is being tested with unit tests. And the Parasoft platform can actually understand which test is covering which part of the code. Next, we can determine in the IDE, but also by comparing the feature runs with the master branch, to detect which code actually has changed. And when we know which code changed, then we can determine which unit tests were actually impacted with the change. Um, by only executing those unit tests, you will still cover like the complete change of your code base. So how would this look like in a real example? So this is an example where the project has more than 4,000 unit tests. So we have like a period of a few weeks here. On the left side, you see like the full run. This could be like part of the nightly build, for example. And there you see like all the 4,000 tests are executed like on a daily basis. But on the right side here, you see the run where we introduce the test impact analysis, meaning that only the impacted unit tests are actually executed. And there you already see that the numbers of the tests that are executed are much lower, often below the 50. And that obviously helps to get like the results much sooner, so that you can get the feedback on your change like almost immediately instead of waiting on the nightly build. So if we then look at the testing pyramid, you might be familiar with the idea here. So in the below here, we see the unit tests, basically explaining here that for if you look at the code base, that you probably want to cover most of your lines with unit tests. So you have to put in most effort, but also have to. The goal is to get like most coverage from unit tests of your code base. And then moving up, you go to like API tests where you maybe do like more positive and negative flows, but maybe not all of the exceptions. But still, you want to cover most of the um, um, of the of the lines that are like reachable through from APIs. A smaller subset of it is usually being tested with UI tests. So UI tests are more focused on positive flows, making sure that the UI works. And at the top you can see the manual testing, which is often still there. That doesn't have to be a problem, but there is always some work which you probably want to test manually as well. But what we see in general is it is often like implemented the other way around. People are putting more effort and trying to get like big code coverage on those higher levels. And that is logic because it's like, yeah, easy to get going. But those tests which are like higher in the pyramid are often harder to maintain. While a unit test might be harder to create initially, it's much easier to maintain on the longer run. And it also executes quicker. So if we then look at code coverage, Parasoft technology can help you to get insight in code coverage. So we can give you the insight on every level for unit testing, obviously, but also for manual testing. This code coverage is all reported to the Parasoft development testing platform, which is a web interface, a web platform where all the test results are aggregated and where results of the different analyzers are presented. And this is an example of coverage. The nice thing here is that you can actually combine the coverage. So if you combine the coverage, you can determine how much of your code base was actually covered with a test, like any test. Well, in this specific example, we are like covering 64% of the lines, and through pairs of DTP, you can get insight in this. So concluding on the smart test execution, and this is what I will show you today for unit testing. Like I said, Parasoft has technology to do this on 3 levels. So today we will look at unit testing, but we can apply the same logic also on API testing and on UI test, Selenium based. So if you like the approach of running a subset of your test, then you can use the same logic for API testing and UI testing as well. But today the focus is on unit testing and showing you how this would integrate within the CI/CD pipeline. So one thing left before we start with the demonstration. Something about static code analysis, where we talked about unit testing a lot, but also static code analysis, where we can actually apply the same logic on the static analysis as well. So there we actually have the same thing. Is that it takes a lot. It can take a lot of time to scan the complete code base, especially if you choose like configurations where you have like very much rules which you want to apply for your static code analysis, and also for feature branches. Parasoft has technology to only scan a subset of your code base, basically the changed code, to speed up the whole process. So without further ado, we will move now to the demonstration part of the webinar. So let me get the correct screens. So this is where it all starts. I already mentioned in the during the slides that Parasoft provides Parasoft DTP, a reporting platform for software development. So DTP gives you all kinds of insight, but one of the insights is obviously the test results, unit testing, API testing, security testing, all kinds of testing, and also code coverage is being tracked here in DTP. And this code coverage, this is actually what we will be using later on. Because what will happen is that the developer, he or she, will work in the IDE. So you have the IDE where you want to make the code changes, and from here we will import the coverage from Parasoft DTP. So I will click on import from and click DTP to import the coverage from DTP. Here you can see that we are like 64%. That is maybe um, could be even this particular code base. Basically, the line coverage is imported from DTP at this point. So when we make changes at this point, we will be able to analyze on which unit test this actually has like impact on. So now we will make a change in the code base. So for example, yeah, this is like a small project parabank. So we have like a couple of classes here. It's actually a decent number, but if you compare it with a real project where you maybe have like thousands of unit tests, then this is like a very small project. But it will show you the concept on how to work with this. So I have one class here. It's a DAO, the data access object, and well, let's create it. Let's make a change in the create customer method here. So we have here the call to process the update. Let's make this a little safer um, and apply a try catch construction over here. Maybe something like this. Now let's report the error. Let's do something like this. This could be a change what we make. So if I now save this change, what we will see is that in this particular view with the impacted unit test, now this information appears that those particular tests are actually related. Let me make this a little bit smaller, like so. So these particular tests are actually related to this particular change. So to test this change, I can just press here on this button to run the selected test. And it will actually, let's get rid of this message for now. It will actually execute only those tests that are related to this to this particular change. So this will give you like feedback quick on all the tests are still successfully. So everything is like correct here. But you see already we don't have to like re-execute the whole code base of unit test. We can just run the subset. A very similar thing actually happens here with static analysis as well. So let's make like an obvious mistake here. Let's divide something with 0 that should trigger some static code analysis. So what we can do here in the IDE is that we can run the static code analysis directly over here. So let me run the recommended rule set. So there are many rule sets built in Parasoft JTest. I can show you them quickly. Unit testing is also very focused, for example, on compliancy. So if you have to comply with the search standard with CWE or various other standards, then you can use the static analysis from JTest to see how compliant you are. But this technology can actually also be used directly here from the IDE. So I can just select this particular class, execute JTest, and it will now perform a static code analysis on this particular file. We have a finding, so let's see what happened. So here we have found a problem, and actually here I had to save the change still before I executed the test. So that's the reason why it doesn't it doesn't show this warning. So let's do another execution of the test. But the main advantage is it goes like very quick, right? So this was already the execution only on this particular file. So now we see we have 4 more findings, or 3 more findings. So this was the one which was initially found before I saved the file. And here you see that you get like some feedback on, in this case, the division by 0. So all the findings from static code analysis are the feedback you get directly within the IDE on everything. The nice thing here is that obviously you have like control here on which set you want to run, which rule set, or you can create your own rule sets using the existing rules. But you can also drill a little bit deeper in what is actually happening. So all of the rules are like completely documented with examples on why this is wrong and how to repair it, and where and references to sources and other material. So it provides you like input on to work with this to understand why this might be a problem for your code base. So this we can already do before checking in. The next step obviously is that we check in the code base in our version control system. So for that, I have this example. We are working on Parabank, and you see we have like different code bases here, different branches. So we are working now in the master branch. We want to we are with the IDE. We are now working in the Selenium demo feature branch. This is where we where we will work on, and this I will show you both in Jenkins and in Azure DevOps to show you how we can perform the test on those feature branches. My first example is based on Jenkins. So I have a Jenkins-based CICD pipeline over here. We have a couple of pipelines. So first of all, oh, I'm sorry. This is let me go back to Jenkins. So first of all, we have the baseline. So that is running the build against the master branch. Then we have the updated one. So this is like a full analysis, the full unit test stat, everything on the feature branch. And the third one in this row is where we implement the test impact analysis. So you can see it actually takes less time to execute this particular test execution. Here for the code base, it's actually very similar to the feature branch. It takes like 5 minutes and 20 seconds to execute the build. However, when we apply test impact analysis, you see that the time is greatly reduced. So let's dive a little bit deeper in how this is actually working. And our Jenkins pipeline, this example, is based on this particular script. The funny thing here is that the nice thing here is that it's all based on Docker instances. So the complete agent, which is doing the build, but also the pairs of components like JTest, are all deployed and executed within Docker. You can actually see the Maven comments here in the different steps that are involved with running this particular pipeline. So let me now also show you the same example, but then based in Azure DevOps. So here we see like a couple of examples. First of all, I have the main feature branch running running all the unit tests. So let me dive into to this a little bit. Let me first show you how this pipeline is configured before we look at the results. So basically everything is Maven based. JTest integrates with popular build systems like Maven and Gradle. Example is Maven based. So here you can see that we have the Maven goals over here. And some of them are based, are instructions to JTest to execute the test. You can see we are now running the unit test. So we have built here or a run configuration, which is pointing to, which is instructing to execute the unit tests. And if we look at the last results, this was one execution which I did a couple of hours ago. It took like a little bit over 2 minutes to execute. And here we can see, if I clear this a little bit out, here we can see all the unit tests which were executed in this particular run. So you see like the total is like 236. But if I now look at the feature branch, then you already see over here that the execution was actually much quicker. It was like well under the minute. So let's dive also into this one. First, I will show you the configuration of this particular project. And here you can see that we are instructing to only execute the affected tests. JTest is using coverage data to determine the change. So with that information, it will then execute the impacted tests. And if I go back to show you the result of the last run, then you can see that we only executed 25 tests to cover this particular change of the feature branch. So to test the change in the feature branch, we only have to execute 25 tests. Well, this is of course a small example. This is based on a very small project, Parabank. But here you can already see that there is like quite a substantial time save here because the execution was much quicker. And this is including like compiling, checking out everything. So really the difference here is on unit testing, where you can see where we gained most of our time, of course. In this same Azure DevOps instance, we also have an example of static analysis. So this was executed, but here the run configuration was focused on doing static code analysis. And here you can see that also those results, like I showed you one in the IDE, one particular finding where we did a division to 0. Well, this is like more realistic data here in this example. You can see that all the findings are reported back to Azure DevOps. So this also helps you to see trends. Is it getting better? Is it getting worse? Well, obviously, you get like real insights within the reporting platform. But this can act like a quality gate to determine if the feature branch, for example, is good enough to merge back in the master branch. For static code analysis, we also provide integration with SonarQube. So if you already if you are like a SonarQube user, then that might be interesting to import the work in your SonarQube platform. so that you can work also with our extensive security compliance scans, and then you can extend your SonarCube functionality with that stuff as well. So going back to the slides, so we look today on how to integrate the static analysis and unit testing in our CI/CD workflow. I showed you 2 examples in Jenkins and Azure DevOps. We looked a little bit into coding standards, compliancy with coding standards, and we focused on impacted tests. So we found like new issues because I changed some code, and we checked only that particular code to get like fast feedback on the modified code. So with that, I think this is time for the questions at this point. Joy, I heard you want to...
Yes, thank you, Ruben. That was a great session. I think a lot of good content covered there and some really important features that can help developers be more productive and let a tool take care of the capabilities, the testing that they need so that they can spend more time on feature development. Go ahead and go back to that last slide. We will take questions. I think we might have a couple in the queue already, but if you do have any questions for us, that would be great. In addition to Ruben, we also have our lead developer, Brian McLaughlin, on the line with us to help answer any questions. So please send them to us. Ruben, can you go ahead back to the last slide with the QR codes, please?
There we go.
Oh, perfect. Thank you. Okay. All right. Well, first of all, if you want to learn more about JTest and our other automated testing solutions that Ruben mentioned, please visit our website at parasoft.com. We have lots of great resources there, including white papers, ebooks, case studies, blogs, and other webinars on demand if you might want to watch those. And if you have questions, please put those in the Bright Talk window. Let's see. Our first question here is, how can we use the data from our sprint to improve quality? Ruben, do you want that, or should Brian address that one?
Well, maybe Brian can jump in here. Yeah, if he is online, I'm not sure.
Brian, are you available?
Excuse me, I was muted. Yes. Apologies. Can you repeat the question, Joy?
How can we use the data from our sprint to improve quality?
Well, that's kind of a large topic, isn't it?
Right. Maybe a couple of examples.
Yeah, so a couple of examples. As we were seeing earlier, there's various ways to collect the data from various sources, from various tools. For instance, you can collect, static analysis violations. You can collect test results. So there's a fair bit of data that you can collect from different tools running different kinds of analyses. One of the best things to do with that data, of course, is to be able to get visibility into it, and then use that as a quality gate, as a decision point on when to merge a feature branch to master. And for instance, if you have failing tests, if you have static analysis violations, obviously you wouldn't want to merge a feature branch onto master, and so you can basically drive your code quality based on that data and on those metrics.
Okay, great. I do think it's a huge benefit with the way DTP has that configurability and lets the users create the dashboard display that's going to work best for them to show the individual coverage areas for unit versus API versus manual, and have that consolidated number two, that merged coverage data is extremely helpful. And the fact that you can drill down into each of those to find where the areas that are potential gaps or issues that need to be addressed.
Right. And as we saw, there's various tools that you can use for that. If an organization is familiar with SonarQube, for instance, or any of these other tools that they're more familiar with, of course, Parasoft tools will integrate with those. So, whichever one you're most comfortable with, it all works together.
Yes. Very much supportive of developer ecosystem tools that are in the industry today.
Yep.
Very good. Okay, the next question is, does the test impact analysis capability help to identify redundant tests that should be removed?
In a word, yes. It's not something that we could easily demo right away, right here, but the answer is yes. And so if anyone is interested in actually seeing that, I would suggest reaching out to Parasoft so that you can see that in action. But yeah, it can absolutely do that.
All right, perfect. Okay, if anyone else has questions, please feel free to submit those. We're going to be wrapping up here shortly. But in the meantime, if you are interested in learning more about anything you've seen today, please do submit a request for a personalized demo. We can get that set up for you so that you can just understand better how the JTest solution can improve your unit testing and static analysis for your Java applications. We've also got this unit testing ebook here with some very helpful tips, including also how to manage your ROI for the managers in the organization who are saying, okay, how do I make my developers more productive? How do I get the value out of a tool like this? This ebook can be very helpful. All right. Well, I'm not seeing any other questions come in. If anyone does have questions, feel free to contact us at our website, parasoft.com. We're happy to follow up with you in any way. And I hope you found this session both interesting and informative. Thank you very much, Ruben. Thank you very much, Brian. Great job today. And thank you, everyone, for attending. Have a great day.